So given a m by n grid filled with non-negative numbers, find a path from top left to bottom right, which minimizes the sum of all numbers along its path. And we have to note that we can either move only down or to the right at any point in time. And for example 1, we have this grid here, 3 by 3 grid, where our path is highlighted in yellow, and this path provides us the minimum path sum to reach this bottom rightmost endpoint. And this program is going to return 7 because that is this path added up all together. And how I went about this is I used a bottom-up dynamic programming approach where I just chose to start from the endpoint as opposed to the starting point. And I worked my way backwards until I reached the starting point. And how I went about this was I created a new 2D array that is one row larger and one column longer than the provided grid array. So in the context of example 1, my new 2D array would be a 4 by 4 grid as opposed to a 3 by 3 grid, and I'll get into the reasoning later. And what I did next was for my new 2D array, I assigned each value to an arbitrarily high value using integer.maxValue. However, I also did initialize the cell under the endpoint. So if it's a 4 by 4 grid, the one down here, to 0, because we're going to work backwards dynamically. And once I had that new 2D array set up, that's when I created another nested for loop that's going to start at this position, at the most bottom right position. Keep in mind we have that extra layer here and here, and the reasoning is because my algorithm works by comparing the given cell's value, or comparing the shortest path by comparing the values to the cell that are below the given cell and to the right of the given cell. So for at the origin here, I'll be looking at which value is smaller, start from to the bottom of it and to the right, and then adding it to the current cell's value on this line here. And so in this case, for example, we are at 1, the cell below it has 0, and the cell to the right has infinite or an arbitrarily high value. And so we're going to pick the smaller one using math.min, which is going to be 0, and we're going to add it to 1. So then in my new 2D array, the positioning here would be 1. And then we are going to do this for the whole entire grid. And at the end, we're going to return 0, 0, which is the top left positioning, because by then we would have calculated the lowest cost sum for the lowest cost path. And so at that point, we have the minimum path sum, and the runtime complexity is going to be O of n squared because we have to iterate through each row and each column using nested for loops, which is going to be n squared. And one thing I'm proud of, as previously stated, is going to be remembering that edge case where we're going to have to add an extra layer for the new 2D array so that we do not get an index out of bounds error because of the way our algorithm works.